If I asked you what this symbol meant, then you'd probably be tempted to tell me that it's percent or a percentage. And you would be absolutely right. It is absolutely the percent symbol, and it is absolutely the symbol we use for percentages. But that wouldn't be the answer to the question that I asked. Percent, or percentages, would be the answer to the question, what does this symbol say? But I asked what this symbol meant. Well, let's think about those words, percent, first of all. Let's see if we can unpick this a little bit. In maths, it's usually important to work out why things are the way that they are. So why is this called a percent? Well, let's think about those words one at a time. Let's think about this word per, first of all. When we use the word per, we tend to mean either for or out of. And in this case, we're going with the out of version of that. And then there's this word cent. Now think about where else we hear that. Centimetres. There are 100 centimetres in a metre. There are said to be 100 legs on a centipede. There are 100 years in a century. There are 100 cents in a dollar. And this word cent just means 100. In the same way that tri means 3, quad means 4, and so on. Cent means 100. So per cent literally means out of 100. And that is the key idea behind these percentages. That we are talking about a certain chunk of 100. If I were to put a number in front of this percentage now, and talk about, for example, 19%. 19% literally means 19 out of 100. It says that if we had 100 things, 19 of them would be whatever we are looking at. If, for example, we said 19% of the cars in a car park are red, then that means if there were exactly 100 cars in the car park, 19 of them would be red. We're out of 100, so that means there would then be 81 cars in the car park that are not red. So 19% of the cars are red, and 81% of the cars are not red. If we change this number, if we had something like 38% instead, perhaps the following day 38% of the cars in the car park are red. That means the following day a bigger chunk of the 100 cars are red, because we've now got 38% as opposed to 19%. So this idea of percentages is all to do with being out of 100. Problem is, it seems to suggest that there have to be exactly 100 objects that we're looking at. What if, though, we look at the car park and there aren't 100 cars in the car park? What if there are 50 or 20 or some other number? Can we still talk about percentages? Well, it turns out, yes, we can. So this idea of percentages and using them to find chunks of a particular number of things is perhaps best seen with a particular example. So what we're going to do is we're going to use these percentages, we're going to break this down into smaller chunks, and we're going to ultimately work towards this particular question. Work out 19% of 40. So this is just a random percentage of a random number, but we're going to get there in stages. We're going to find some other percentages first that will help us along the way. Key thing that this hinges on, this idea of 100%. Well, if we're dealing with percentages as being out of 100, then everything, the whole thing, is 100%. And that's our starting point. So 100% must be the whole 40. Now, we could use that 100% to find some other useful percentages. 19% isn't going to be that easy to find on its own, but we could find some other useful ones, and they might help us get there. It might be that all of these are helpful, it might be that just some of them are helpful. We could, easily enough though, if we know that 100% is 40, we could easily enough find 50% of something. How can we use 100% to find 50%? Well, what's the link between 50 and 100? Two 50s make up 100. As in, 50 is half of 100. So if 100% is 40, then 50% must be half of the information. So 50% must be half of 40 at 20, i.e. we have divided both things by 2. We have divided by 2 to find the 50%, and we've divided the total to find the 50% as well. Could we use 50% to find a useful one? Well, yes, we could, because surely we could then find 25%. How? Well, we could just divide by 2 again, because 2 25s make a 50. So if we divide by 2 again, we can do half of the 50% to get 25%, and so half of the 20 will give us 10, and 25% will also be 10. And that makes sense. How many 25s do we need to make up 100? Or 25, 50, 75, 100, that's 4 of them. 4 lots of the 10 will give us the 40, and that will take us back to where we started. Are any of these particularly helpful to get to the 19%? Well, not really, although I suppose we know that 19% is going to have to be less than 10, because if 25% is 10, 19% must be less than that. It will be a smaller chunk. But these are easy ones to find. And while they're not that useful for the 19%, they might be useful for other percentages. But maybe there are other percentages that we can find in this similar kind of way. So we have once again that 100%, everything we're dealing with is the whole of the 40. We could, for example, use the 100 to find 10%. How are we going to find 10%? Well, how many 10% make up 100%? There are 10 tens in 100, so that means if we divide by 10, we will be finding 10%. I need to make this very clear at this point. I am not dividing by 10 because it's 10%. I am dividing by 10 because 10 of these make up this. When we were finding the 50%, we didn't divide by 50, we divided by 2, because 2 lots of 50 make 100. So we're dividing by 10 here because 10 tens make 100. But if we divide by 10, dividing the percentages by 10 will give 100 down to 10%. So dividing the answer, the 40, will give me 4, and 10% must be 4. 10% is an easy enough one to find. We could also use the 10% to find one extra one. We could use the 10% to find 5%. How? Well, if we just half the 10%, half of 10% will be 5, so halve the answers, and 5% will be 4 divided by 2 is 2. And 5% of 40 will be 2. So there's another set of easy to find percentages. We could start from the 100 and halve it to find 50 and then halve it again to find 25. Or we could start from the 100, divide it by 10 to find 10% and then halve that to find 5%. There's one more thing that we could do, one more useful common percentage we could find. And we could get that one by starting from the 10% again. So we've started from the 100%, we've broken that down, we've divided by 10 to find the 10%, because 10% make up the 100%. But maybe we could use the 10% to find 1%. That's quite a small percentage, but that would be quite useful sometimes. How are we going to find 1%? Well, we can divide by 10 again, because 10 1% will make up a 10%. If we do that, we can divide by 10 for the answer part. We could do 4 divided by 10. Think about where the 4 starts in our hundreds, tens, units grid. It starts in the units. We're dividing by 10, so it's going to shift down 1 column. It's going to cross that decimal point, and we're going to end up with 0.4. So again, we've found another string of percentages. We could start from the 100, divide it by 2 to find 50, divide it by 2 again to find 25. That's one option. Our second option, we start from the 100, we divide it by 10 to find 10%, and then halve that to find 5%. Or maybe we could do the 100 down to the 10, and then divide by 10 again to find 1%. But then that begs the question, what's the point of finding all these simple, smaller, easy to find percentages? Let's go back to this question that we started with. Work out 19% of 40. The key thing about finding all those easy percentages is that we can do those without a calculator generally. because now we can look at this question and we can say we need to work out 19%. Well, that's quite difficult. But we could start with the 100% is 40. We could then find all of those easy percentages that we can work out. We could say, well, we could just find half of that to get 50%, so that's 20. Half of that to get 25%, so that's 10. Or we could do 100% divided by 10 to get the 10%, is 4. Half that to find 5% is 2. Or we could do 10% divided by 10 and get the 1% is 0.4. So these are all of the answers that we got before. But we can then use these percentages together to find the 19%. How? Well, there's a couple of ways. We could, for example, say, well, what if we do 19% is a 10% plus a 5% plus 1, 2, 3, 4, 1%. 10, 15, 16, 17, 18, 19. We can swap each of those out for the particular numbers that we're dealing with. So that's a 10% is 4, plus a 5% is 2, plus 1, 2, 3, 4 0.4s, plus a 0.4, plus a 0.4, plus another 0.4, plus another 0.4. We can pop all of those together and we can get a final answer of 4, 5, 6, plus those 4 0.4s is 7.6. And 19% of 40 is 7.6. Is that the only way we can do that? Of course not. 19%, well, surely we could have, what about 2 lots of 10%? Well, that's 20%, and then take away a 1%. That would leave us with 19. Do we get the same answer? 2 lots of 10% is 4 add 4 is 8. Take away the 0.4, 7.6 as well. Key thing being, doesn't matter which way we go about this, these simple percentages are easy and quick to find as long as we remember how to find each of them. And then we can put them together in different chunks to find the percentage that we need. To prove how quick this can be, let's do another example. Work out 77% of 60. So, different percentage, different number, but we could still go about things in the same kind of way. We could find those nice, easy percentages, and we could then build them up into the 77 in some way. So we start with our 100%. Now, 100% is everything, which means that 100% must be the 60. We can use that 100% to find, easily enough, 50%. How do we find 50%? Well, we divide by 2, because 2 50s make up 100. So if 100% is 60, then 50% must be half of that at 30. We could halve that again to find 25%. So half of 30 is 15. There's our first set of percentages that we could use. We could also, from the 100%, find 10%. Well, 100 divided by 10 would give us the 10%, because 10% make up 100. Which means 60 divided by 10 is going to be 6, and 10% will be 6. We could halve that to find 5%, so 5% will be 3, or from the 10% we could find 1%. We need to do 10% divided by 10 to give us the 1%, so 6 divided by 10 will be 0.6. All we need to do then is we need to put these together in some way to get to the 77%. There are a couple of different ways we can do this, and you get to go with whichever one you spot, but these are nice easy percentages that we have written down. We can just use those and build up to what we need. We need 77% ultimately. So we have a look at what we've got. Well, we could do maybe a 50% plus a 25%, that's 75%, plus 2 1%. And again, there's a couple of different ways of doing it, but that would get us where we need to be, 50, 25 and 2 1s. Swapping those out for the numbers then, 50% is 30, 25% is 15, and then 2 1% is 0.6 each. Adding those together then, we would get 30 plus 15 is 45, 0.6 plus 0.6, 1.2, so 46.2 as a final answer. These questions where they're asking you about the numbers, it could just be the number 60 like it is here, in which case the answer is 46.2, or they could make the question have a bit more context to it. It could be something like £60, say, or 60 whatever. And if it is £60, then we have to make sure the answer matches that. So our answer would then, in that case, be £46.20. But it's the same method all the way through. Find the easy percentages that we can, because they're nice and quick to do, and you'll get into the habit of being able to do those nice and quickly, and then put them together in some way to find the percentage that you need. The most basic type of percentage question is basically exactly that. Find a given percentage of a given amount. And the only other type of percentage question, really, that's just talking about percentages that they could possibly ask is one that gives them a little bit more context. Because you think about percentages, there is absolutely a use for them in everyday life, and we will all have come across them at some point. The classic kind of contexts are where they talk about percentages in terms of things like shopping, going shopping and seeing a sale, a discount of a certain percentage, or thinking about something going up by a certain percentage. You could talk about, say, a population increase. The population has increased by a certain percentage. So this idea of percentage increase or decrease, and actually they're very similar questions at their most basic. There are two types of percentage increase questions, and the first is where you yourself are doing the increase or the decrease. A book costs £20. The book is marked for a 12% discount in a sale. What is the sale price of the book? Now this question is exactly one of those. Here is a particular amount, a percentage that you're given. You yourself have to do the percentage change. What clues are there in the question that it is one of those type questions? Well, you are told the original price of the book. The book is £20. And the question asks for the sale price. So if you see words like that, if you see a question asking you for the sale price, or asking you for the new price, or asking you for the price after the discount or after the increase, it is one of these first type of questions where you yourself do the percentage change. And these are actually quite straightforward because they are exactly the same as the previous questions, where you first step work out the percentage of the amount, and then the second step either add it on or take it off, depending on whether it's a percentage increase or a percentage decrease. So we're dealing with the £20. We are working out the sale price. To work out the sale price, we need to work out how much money has been taken off, and the amount of money that's been taken off is 12% of the £20. So we need to work out 12% of 20. Well, 100% is the whole 20. We could then go through this process of working out the other percentages. Well, if we know that 100% is 20, then 50% will be half of that and will be 10. 25% will be half again, and 25% will be 5. Or, from the 100, maybe we could work out 10%. Well, to find 10%, we divide our original price by 10. So we're going to do 20 divided by 10 is 2, and 10% is 2. We could halve that to find 5%, and that would give us 1 for 5%. Or we could do 10%, we could divide it by 10. 10% divided by 10 would give us the 1%, and 2 divided by 10 will be 0.2. Or 20p, if you prefer. We need to put these together, and we need to put these together to get 12%. We want to work out the 12%. Well, why don't we do a 10% plus 2 1%? So that will be 10% is 2, plus the 0.2, plus the 0.2 is £2.40. £2 plus 2 lots of 20p is £2.40. That is the amount of money that is being discounted. We need to work out the sale price of the book, so it's important to look back at that question, work out the sale price of the book. So we're going to have to do the £20 less the £2.40 takes us to £17.60, and that's our final answer. That makes sense in context. The sale price is obviously going to be less than the original, and we ourselves have made the percentage change. This type of question, where you yourself make the change, could be a discount or it could be an increase. The question will make it fairly obvious which one it is. Something has increased by a certain percentage or something has decreased by a certain percentage. The word discount in this question tells us it's a decrease, and the idea of sales and sale prices tips us off because we understand how they work. But again, this is a type 1 question. Well, we are asked for the sale price of the book. We're asked for the new price after the discount's been done. So we ourselves make the percentage change, work out the percentage, and either take it off or add it on at the end. But then, of course, things get a little bit more complicated, because of course they do. A shirt is in the sale for £31.50. The shirt is marked at a 30% discount. How much was the shirt originally? This question is different from the previous one, and this is a second type of percentage change questions. To see how it's different, we need to really examine the question and work out what we're being asked for this time. What's different about this question is that now we are given the discounted price. We are given the price in the sale, and we are asked to find the original price. So we're working backwards. We are undoing a change that's already happened. Now you might be tempted to say, well, surely we just find 30% of the £31.50 and add it back on, and that will take us back to the original. Problem is, it won't. The sale price has been obtained from doing 30% of the original amount. Now, we don't know what that is. If we were to find 30% of £31.50, well, we could do that, and that would give us an answer. That would give us a number. Problem is, this original amount, we don't know what it is, but we do know that it's bigger than £31.50. If this number is bigger, 30% of this will be bigger than 30% of £31.50. We don't know what this is, but we do know that it will have to be bigger than the answer to this because it's 30% of a bigger number. And if 30% of the original is not going to be the same as 30% of £31.50, that's not a way that we could do this question. So we're going to have to do it in a different way. These are the second type of these questions. And the second type of these questions is where you are undoing a change that's already happened. Let's think about where that sale price has come from. We've had an original amount. Then we've taken away a discount, and that's given us the sale price. Now, we do actually have some of these pieces of information. We could swap out the words for the actual numbers and percentages that we're given in the question. The original amount must have been 100%. We don't know what that is, but we do know that it will have been 100%. The discount was 30%. And we also happen to know that the sale price was £31.50. We don't know what this 100% was, and we don't know the number, the numerical amount of the 30%, but we do know that if we've had 100% and we've taken away 30%, well, we must be left with, what must we be left with? Well, 100 take away 30 is 70%. We are left with 70% of the original, and the 70% here is £31.50. How is that helpful? Well, because we now know what 70% is. So maybe we could try and turn 70% into 100%, scale it, times or divide it by something, maybe, to get from 70 to 100. Is there anything we could times 70 by easily to get to 100? Well, probably not, actually. But maybe we could turn it into something else first. Could we not, for example, divide it down to find 1%? What would we have to divide 70 by to find 1%? Well, surely 70 divided by 70 would take us down to 1. Why is that useful? Because we could divide the answer down as well. We could do £31.50 divided by 70, and that would find us the value of 1%. So we could grab our calculators, we could do £31.50, we could divide it by 70, and that would come out as an answer of 0.45 or 45 pence. Why is that useful? Because surely now we could scale back up to find 100. How can we find 100% if we've got 1%? Well, how many 1% do we need to make 100? Well, we just need 100. So we could times by 100 on both sides, and that would scale us back up. 45 pence, we times it by 100, we get 45 pounds. And 100%, i.e. the original amount, must have been 45 pounds. We have a way we could check that as well. We're saying that a discount of 30% will get us from 45 down to £31.50. So if we just quickly work out 30% of £45 and take that off, then we should get down to £31.50. Well, 10% will be £4.50, so 30% will be 3 lots of that. Well, 2 lots of that is £9. 3 lots of that will be £13.50. 45, take away the £13.50, is indeed £31.50. So it works. So the original price must have been the 45. And see, this question is a second type of increase or decrease by a certain percentage question, where the percentage change has already happened and we are trying to undo it. And you have to be able to look at these questions and work out whether it's a type 1 where you do the change or a type 2 where the change has already been done for you and you're undoing it. And there are certain clues in the wording of the question. If a question asks you to find the sale price or the new price or the price after the increase or the decrease, then it's a type 1 question. Alternatively, if a question talks about finding the original price or asks you what the value was originally, then it's a type 2 question where you are undoing the change. And to undo the change, you simply need to work out what percentage you have now. We'll do one more and we'll see if we can work out, first of all, which type of question it is, and then second of all, solve it. A loan charges 15% interest per month. At the end of the first month, the loan is worth £1,035. How much was the value of the loan originally? So first question, is it a type 1 or is it a type 2? Well, the question is talking about how much the value of the loan was originally. In asking us for the original price, that means the increase or decrease has already happened, and we need to undo the percentage change to get back to where we started, because we're being asked to find the value of the loan originally. If it's a type 2 question, then we need to work out what percentage we have of the original amount. So we're going to have to think about how the loan works. Well, the idea is that we take out a loan for a certain amount, and then after the first month, well, we've got this idea of interest. So interest is value added on top of something. So 15% interest per month means we've had the original amount and then we have added on this time 15% of the original. So we've added on the interest and the amount that we have to pay back, the value of the loan has gone up because the interest has been added on. So the amount that we've got to pay back has gone up. So it's increased this time. And that's given us the new amount, the new value. Now we know some of these. The original amount must have been the original 100%. The interest was an extra 15% added on, and the new value is £1,035. If we have got the 100% original and 15% extra, then what percentage do we have now? We have 115%. But surely we can't have more than 100%. Everybody always says you can't give more than 100%, and yet you can. If 100% is everything that you started with, having more than that just means you've got more than you started with. So having 200%, say, means it doubles in size. You've got twice as much. 115%, say, is everything you started with plus a little bit more. So it is absolutely possible to have 115%. So then, 115% is the 1,035. It's the 100% original plus 15% extra. And that is worth 1,035. But we don't want 115%. We want just 100% on its own. Is there any way to easily get from 115 to 100 by simply timesing or dividing by a single number? Probably not, really. So maybe we could go via another value. Maybe we could do what we did before and go via 1%. We could scale down to 1% and then we could scale up to 100%. Or we could scale down to 1%. What do we need to divide by to find 1%? Well, if we've got 115, what do we need to divide 115 by to get 1? Well, 115. So we're going to do 115 divided by 115 to get 1. Which means, on the right-hand side, we also have to divide by 115. We nip off to the side, maybe, with our calculators. 1,035 divided by 115. And we get 9. But then we don't want 1% either, we want 100%. So how do we scale back up to get from 1 to 100? Well, we simply times by 100, which means we do exactly the same on the right. So we do 9 times 100, giving us a final answer of £900. And the value of the loan originally will have been £900. So we knew this was a type 2 question. Well, we've got to undo the increase or decrease, increase in this case. And the original amount will have been less than the 1,035, which it is, at £900. We could check that, because if we work out 15% of that £900 and add it on, we should get to the 1,035 that we started our question with. Well, 10% of 900 will be 90, 5% will be half of that at 45. So 15%, the 90 and the 45 is 135, and 900 plus 135 is indeed 1,035, giving us the new value that we started our question with. So the numbers all work, and the original value of the loan must have been £900.